Hello everyone and welcome to Network Playroom. This is the 14th video in the Christmas calendar series and we're still continuing with the spanning tree theme. So we've been talking about the basic operation and mechanics of the spanning tree protocol in previous videos, but the spanning tree protocol is actually not just one protocol. There are several different flavors of the spanning tree protocol. And while a lot of the core topics I've presented in other videos is true for all spanning tree versions, such as the selection of the root switch and determining the forwarding and blocking ports, there are distinct differences between them. And this video will provide a brief overview of them. So I'm using an excellent document from packetlife.net to summarize the most important information. And this chart briefly introduces the key differences between each spanning tree version. So this is such a fantastic document. I've used it myself many times and it has helped me learn spanning tree protocol. A big thank you to the author Jeremy Stretz. So I'll leave a link in the description, so go check it out. Okay, but let's start from the left and go over each version. But actually, the first thing to note here is the algorithm. So the first three flavors are running legacy spanning tree, and the following three are running rapid spanning tree. So we're looking at this section here. So notice that this is the same for the first three versions, and then the other three are using rapid spanning tree. So what does this mean? Well, without getting into the details too much, rapid spanning tree builds on and adds enhancements to the legacy spanning tree, which results in faster convergence, and hence the name rapid spanning tree. Rapid spanning tree can be seen as an evolution of legacy spanning tree more than a revolution. So it's not like legacy spanning tree was completely thrown in the garbage and the protocol was totally redesigned, but actually the terminology remains primarily the same and most parameters have been left unchanged, so users familiar with legacy spanning tree can quickly configure the new protocol comfortably. The biggest improvements happen behind the scenes in algorithm optimizations, which we'll not get into now. So the first version is the legacy spanning tree protocol, which is the original specification of the spanning tree protocol defined in 802.1d. And this version is sometimes referred to as common spanning tree, or CST, because it assumes one spanning tree instance for the entire switched network, regardless of the number of VLANs. So this one right here, this is the root of everything, or the mother of everything, defined in this standard, and it only supports one instance of the spanning tree topology. So the next one, PVST, is a Cisco enhancement of the spanning tree protocol that provides a separate 802.1d spanning tree instance for each VLAN configured in the network, and it uses ISL encapsulation. So how this is different from the legacy spanning tree protocol is that this is a Cisco proprietary protocol, as you can see here, and it uses per VLAN instances and ISL encapsulation. This is a Cisco specific encapsulation that is really not in use anymore, but I won't get into the detail of that protocol right now. So let's move on. PVST Plus is effectively the same as its predecessor PVST, but it also uses 802.1q encapsulation. So again, this is Cisco proprietary and then per VLAN instances, but now this one is added, 802.1q encapsulation. So that's really the main difference between those. So that little plus there indicates the addition of 802.1q. And then RSTP, or Rapid Spanning Tree Protocol, which is defined in IEEE 802.1W standard, is an evolution of the spanning tree protocol that provides faster convergence than STP. However, RSTP still only provides for a single instance of spanning tree, and Rapid STP was later incorporated into the 802.1D 2004 standard. So this one right here, this one's the first one to use the rapid spanning tree algorithm, and here is the original standard, but then it was later incorporated into the 802.1D 2004 standard, and still it supports only one instance of spanning tree. So next there's Rapid PVST Plus, which is a Cisco enhancement of RSTP, and it's similar to PVST Plus. So Rapid PVST Plus provides a separate instance of 802.1W per VLAN and uses both 802.1q and ISL encapsulations. So this is another Cisco proprietary protocol, just like PVST or PVST Plus, and it supports per VLAN spanning tree instances and also supports both encapsulations. And then finally, there is multiple spanning tree protocol. So Mstp is an IEEE standard inspired by the earlier Cisco proprietary multiple instance spanning tree protocol, or MISTP, implementation. So Mstp maps multiple VLANs into the same spanning tree instance. And the Cisco implementation of Mstp is MST, which provides up to 16 instances of RSTP and combines many VLANs with the same physical and logical topology into a common RSTP instance. So you can tell that MST is different from the others because the number of spanning tree instances is not tied to one single instance or per VLAN instances. This is actually configurable, and you can combine several VLANs into one instance. And this field contains the standards that define MST. And again, it supports both encapsulations. And in these nice diagrams below here, you can see the essential differences. So legacy spanning tree, it supports only one instance. So this is the only topology that you can have. Oh, no, that looks kind of funny now, but we'll let it pass. But compared to PVST Plus here that has per VLAN implementation, you can see that you can have different links forwarding and blocking for different VLANs. So for example, here between switches A and B, all links are forwarding for all VLANs, but there's a separation from switch C. So only VLANs 1 and 10 are forwarding on this between these two switches, and then VLANs 20 and 30 on these links between switch C and switch B. That's how you can do balancing between the VLANs, by the way, using spanning or per VLAN spanning tree protocol. You can also do that with MST because you can configure those instances and make one switch the root switch for a certain instance and another switch, the root switch, for another instance, which is essentially what they've done here. So switch A is the root switch for instance 0, and switch B is the root switch for instance 1. So you can see it here. So from switch C's perspective, instance 0, which contains VLANs 1 and 10, are forwarded using the red link, and instance 1, which contains VLANs 20 and 30, are forwarded using the blue link. So if we had the situation where switch A was the root switch for both instances, then both of these links would be unusable. So only the red link would be forwarding. So that's the benefit of having a per VLAN spanning tree or per instance spanning tree. But yeah, that was a quick look into the different spanning tree flavors. Thank you for watching, and I'll see you in the next video.